So when you're solving an equation, the goal is to get x by itself, so we can find the specific value of x. To do this, we have to undo the operations that are being done to x. We can see here that x is only on the left side of our equation in one place, and if we knew what x was, we would multiply it by 2, and then we would subtract 9. So in order to solve for x, we have to undo those operations of multiplying by 2 and subtracting by 9, and we undo them in the opposite order that they're being done. So the first thing we're going to undo is the subtraction of 9, and the inverse operation for subtraction is addition. So we're going to add 9 to undo the subtraction of 9. We have to add 9 on both sides to keep the equation balanced. To stay organized, we usually draw a line underneath that work. Now, if we had negative 9 and added a 9, together that would make a 0. And so all we're left with on the left side is 2x. So we rewrite the 2x, we rewrite the equal sign, and we do 21 plus 9 and get 30. You can see we have a simpler equation to solve now. The x is still being multiplied by 2, so we have to undo the multiplication using the inverse operation of division. So we'll divide both sides by 2, and we use a fraction bar to show division when we're solving equations. And when we divide both sides by 2, you can see what we have here on the left is actually 2 divided by 2. And 2 divided by 2 is just 1. So really what we're left with on the left side is just 1x, or just x. We'll rewrite the equal sign, and then we have to do the division step. And 30 divided by 2 is 15. So x is by itself. We know that 1x is equal to 15. We've found the value of x that makes the equation true. So our goal here is still the same. We're trying to find the value of x. We do that by isolating x, and we isolate x by undoing the operations that are being done to x. So if we look at where x is in the equation, we can see it's only written in one place in the whole equation, so we can start to isolate it. We have to look at the operations that are being done to x. So if we knew what x was, to be able to find the value of the left side, we would have to take this x and multiply it by 5, and then we would do 8 minus that result. And this is according to the order of operations. So if we knew what x was, we would multiply first, and then we would subtract. Remember, when we're solving, we undo in the opposite order. So that multiplication that's being done to x, we're going to undo that in our second step. Our first step is going to be to undo what this 8 is doing over here on the left side. Now, at first glance, you might think that this 8 is part of a subtraction step, and we should undo it by adding 8 on both sides. But if we make one small change to the equation, we can see that that won't be the correct first step. If you remember, if we see subtraction, we can replace that subtraction with adding the opposite. So really what we have instead of 8 minus 5x is 8 plus a negative 5x. And then what you can see is that this 8 is really being added instead of being subtracted. So to undo the addition of 8, we're going to subtract 8 on both sides. And then if we look here on the left, we can see a positive 8 minus 8 actually makes a 0. And all we're left with is negative 5x on the left side. And that's equal to negative 27 minus 8, which is negative 35. Now x is being multiplied by negative 5, and we can undo the multiplication with the inverse operation of division. So we'll divide both sides by negative 5, and x is equal to positive 7.